Okay, so looking at Clipper circuits again, let's look at a few other scenarios. So this first scenario is different than the last scenario in that the direction of the diode has been flipped. Okay, so now the diode would be biased by a voltage of this polarity. And we still have V bias, which is positive with respect to ground. So V bias is somewhere like this. And we know that that because of this polarity now, this diode will be forward biased if this supply voltage is below V bias. So if the supply voltage is below V bias, then this is going to forward bias this diode. When the diode is forward biased, it's cutting off the, it's, we're assuming it's acting like a short, so we're ignoring the 7.7 volt drop across the diode, and it's limiting the output voltage to 2V bias. So thus on the output, whenever the input falls below V bias, the diode is forward biased and the output is cut to V bias. And you can see that because if this is the polarity of the input voltage and the value of this is bigger than this V bias, then the resulting polarity that we're going to end up with is like that. And so that's not going to forward bias the diode. But if the magnitude of this supply voltage is less than V bias, then the resulting polarity will be that of V bias, which is like so. Okay, and then and that would forward bias the diode. Now, if the supply voltage goes to the negative cycle where the polarity is this, then automatically it's acting to it's automatically acting to forward bias the diode, and so is V bias. So definitely for this cycle, it's forward biased anyway. Okay, so let's clear that case and we'll look at the next case. So case 2, the diode is back to pointing the way it was in the original question, but the voltage source has been flipped around. So now when we're thinking about this, we have to keep in mind that V bias with respect to ground is down here because the positive of V bias is connected to ground and this point is negative. So we're talking about a minus V bias in this case. Okay, so we've got minus V bias. And so, yeah. So V bias has a polarity like so. In order for the diode to be forward biased, it needs a polarity of this. For the positive cycle of the waveform, we're going to have a polarity like so. The resulting polarity across the diode is going to be forward biased no matter what, because if we follow these positive signs around, that will forward bias it and that would forward bias it. So for the positive cycle, the diode is on. If it's on, the output voltage is automatically limited to minus V bias. So automatically for the positive cycle, we're limited to minus V bias. Now let's look at the negative cycle. So for the negative cycle, the polarity of the supply remains the same and the polarity that we need to forward bias the diode remains the same. But the power supply now has now has this polarity. Okay, so this will only, this by itself would act to reverse bias the diode. But if the magnitude of this is less than V bias, then the resulting voltage will be in the same direction as V bias, which acts to forward bias the diode. So when the supply voltage magnitude is less than V bias, which is here, the diode will still be forward biased and the output will be limited to V bias. So that's this region here. When the magnitude of the supply gets larger than minus V bias, the resulting polarity across the diode will actually now be this, which reverse biases it, and we end up with the same shape as the input waveform. Okay, so that's case 2. And let's clear that and we'll do case 3. So